favors is when teachers see like, oh, okay, you're writing down the notes, right? You're doing your part, and then the rest we can deal with, right? Okay. So a supplementary and complementary angles. So I will do one example for now, and then you'll have some time to kind of try them out. Yesterday we talked about supplementary angles. I'm going to make them look a little different. So if you have a straight line, right, and you've got an angle like that, and that's a 180 right there. If you cut that, and this is 50, let's say, you should immediately know that that's 130 degrees on the other end, right? So if you see this straight line, okay, that if you see that straight line, then you know that is 180. If I have one side, I can find the other. Okay, that's number one. Complementary is a little different. You've got the 90 there. So if you have, let's say, another angle coming in there, if this is 30, here, you should immediately know that this is 60, right? You've got your 90 happening there. So you notice that there's a sharp corner, and it's being split, and you may have one or the other that can help you out. The other one that I didn't talk about it explicitly, but it's coming your way soon, is this one. Can you please sketch that here? Try to copy what I'm doing here. I need you to be comfortable with this notion. I think now I'm doing trig in the morning as well, so sometimes I mix it up, so I'm not sure what I've told you and what I haven't, okay? But if it's 40 degrees here and it's 47 degrees here, okay, I would expect you to be able to figure out what this is. Can you see the 47? Probably not. There you go. So if this is 40, if the small one is 40, and the big angle here to the top line is 47, right? You go 47 minus 40 is 7 degrees, right? That is this one right there. So you got to make sure, look, page 34. You got to make sure you don't think that the 47 belongs to the, some students think that the top here is 47 when they see that. That's a big no-no, okay? Got to make sure you distinguish that. So these are things that we're going to throw into the mix right now, okay? Do you see a straight angle here? There's a 180 happening there, right? So technically, if you knew this angle, you could figure out that angle, and then so forth, right? So that's another, a bit of a combo here. All right, let's solve this particular example here. The value of angle EFD, put your pencil on EFD right now. If you think you know where EFD is, if I ask you angle EFD, could you find it? And if not, look up here, EFD. You connect those 3 points in that order, E, F, D, and then keep going back and forth, right? And now you realize, okay, it's this angle here that we're talking about. These are the ends, E and D are the ends, but F is the middle point where they merge. So that is the angle right here. If you have a hard time constantly having to think where it is, call this X, and then just say angle X right underneath it. It's like, okay, that's the angle we're talking about. And the angle D is up here, right? We know that that's D. We don't need another 3-letter notation for that. Okay, so what would this angle be right here? Angle X. Any brave volunteers? Do you see a straight line here? Do you see that 70 just lingering there? Do you see that straight line right there? Let's make this nice and clear. Okay, you've got the 180 happening there. So if this is 70, if this part right here is 70, then this must be 110, right? Because they have to add up to 180. So I'm going to show the work here. I will go 180 minus 70. That's 110 degrees. Okay. I can guarantee you that I will make this happen on the test, okay, one of these questions. And the province has done that quite often as well. Now that you know that this is 110, that's this one right here, right? Just here. We can find angle D. So angle D, once you've got two angles in the triangle, I mean, it's just a ripple effect, right? So we go 180 again. We subtract the angles we know. Okay? So that would be 30, right? Okay. Sure. Sure. Andy, you're being summoned. 180 minus 40 minus 110, that's 150 that we're taking away, so that'd be 30 degrees, right? So there you have it. 30. We wanted angle D, and we wanted angle, we call it X, but it's angle EFD. Please, I need you to be okay with the 3-letter angle notation. I need you to be okay. So just keep connecting them as many times as you need to until you start seeing the angle that is formed, okay? Next, so write this in here as well, 30. So this 70 that was apparently outside the triangle came in, and then once you have that second angle, we could find a third one. So it kind of just was the golden ticket to our solution here, okay? So next, please calculate the length of sides ED and DF. Side ED is this one right here. Let's call it something. Let's call that Y. Okay. And where's side DF? DF is this side right here. So let's call that Z. Okay. Would you be able to solve it at this point? I hope so, right? I hope you can solve it at this point. Let's draw this out here, just a clean version of it. Without this stuff outside, right? So this is E, this is D, this is F. We've got the 40 in here, we've got the 110, we've got the 30. We've got the 1539 kilometers down here. And the 70, don't worry about it, right? We no longer care about the 70 that was outside. This is side Y, and this is side Z. That's essentially what I'm being asked to solve for. What law would I use to get me started? So quiet. This angle, right? You see a side length, and you see the angle across from it. Yeah. Sine. Thank you. Sine law. So sine of 30 over 1539. No units, really. You don't need units here. And if I want to solve for side Y, I must use 110, right? The angle 110. Yeah. So you must use 110 here. So sine of 110 degrees over Y. Cross multiply and divide. Okay, so 1539 times sine of 110 over sine of 30. So there we have it. That is 2,892.37 kilometers. So please remember your sine law, cosine law, that's what everything revolves around, right? You knowing when to use which law. So this is side Y, which was technically labeled as ED by the text, but that's the one we're solving. Next, I'm going to use the same pair divided by 1539. And instead of 110, I'm going to now use 40 to find the side opposite to it. Okay, so sine of 40 over z. Z is equal to 1539 so these two multiply and then divide. So side Z is 1978.50. There you have it. So this is just an added layer, and we'll see how that goes. All right. I'm going to ask you to try right now. Try page 35. I'm just going to warn you, okay? They're not all the same, okay? They're not all the same, so you have to read carefully. Which law do I need to use? Is it SAS? Is it side, side, side? What is going on here? Do I have a pair? If you have a pair, it is sine law, okay? No question about that. So try 35 and then 36. Go ahead. What I'm going to do is, if you want to do this, 35, so I would encourage you to copy this down even if you did it on whiteboards, just to have it in your notes, right? So the dish looks up at a plane as depicted below. Calculate the angle of FUN, right? So it's this angle right here that is formed right there is what they're asking for. So angle FUN is 180 minus 50. So it's 130 degrees. Okay, so this is 130. Some of you might need to sketch out when it's too busy in there. Just copy down the information that you absolutely need. Okay, so what do you have there when it's like that? What case are we talking about? Side, angle, side, right? So we know that that's cosine law. Let's call this x. So it'll be x squared is equal to 1.86 squared plus 2.75 squared minus 2 times 1.86 times 2.75 times cosine of 130. Okay. And next would be the step where it's x is square root of whatever you get when you enter this whole thing, okay? So that would be 17.597 and so forth, okay? So x ends up being 419 miles. So that's your side there, okay? All right, let's keep going. Angle of elevation, right? You want the angle of elevation between the ground and Nitish's line of sight. I'm basically giving it away. I didn't have to say this here, this part. Angle of elevation, you know, it's between the ground and the line of sight going up. It's gonna be like this, or if you're looking at it from the right side, it would be this one, right? So we're asking for one of those angles. There's no doubt about that, okay? So in this case, I'm asking for this angle here. what can I do to solve that? Because I now have the 419 here, right? I'm going to write that in. 4.19 is known to me. What does that turn this triangle into? What case? Ignoring the 130, you have side, 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 right? So you could use cosine law to do that. You could use sine law to do it, because you could use sine of 130 over this, and then this side would allow you to solve for that. I'm going to use sine law because I need you to know how to do that. So you would go sine of 130 over 4.19, and then I would go sine of n, because at this corner here we can call that n. And this is 1.86. Right? So then cross multiply and divide. So sine of n is 1.86 times sine of 130 divided by 4.19. Okay? If you plug this all in, you should get a number that starts with a 0. When you're about to find an angle, it better start with a 0, or else you've made a mistake, right? It's not going to be able to do it. You're going to get an error message. N is sine inverse of that decimal that you still have on your calculator. And that gives you 19.88 degrees. If you used cosine law, did anybody use cosine law? You get a different answer, right? If you use cosine law, using the side, 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 right? If you do the work, angle N is actually 19.97, and it has to do with rounding, okay? That's fine. Just show your work. You will not lose marks if that happens, okay? Last one, I didn't show you this one yet, but it's time for you to learn how to do that now. It says calculate the height of the plane above ground, and the height makes a 90 with the ground, right? Can you sketch this here real quick? Because the diagram up there doesn't do it justice. I will just show you here what I mean. The height is measured from the plane here straight down. This is technically the height right here. But it's very crowded here, so I'm going to make a copy of it. So we're going to go down to question D here. We're going to exaggerate that slant a bit. This is the plane up here. And so you make a dashed line straight down, and you extend the ground here. And we know that they meet at a 90. So this is your height. What do we know from the previous triangle? We knew that this is 1.86. Do we know this angle right here? Yeah, okay, some of you are with me here. So that is 50 degrees. That was already given to me by that original triangle up there. And look at this, you've got a pair here. The 90, right? You know 90 is across 1.86. The 50 will allow you to find the height. Okay, so all we do is sine of 90 over 1.86, and then it's sine of 50 degrees over h. Okay, 1.86, cross multiply like that, and sine of 90. Here we go. Height is 1.42 miles, okay? Everything is in miles in this scenario here, so it's 1.42 miles is the height of the plane above the ground. So we have to insert the dashed lines to make this work. And I hope you understand that there's a right triangle, but sine law, cosine law work with right triangles just as well, okay? They can solve any triangle, any situation, as long as you have the information you need. Okay, I'm going to leave this